What's going on, YouTube? Been thinking about doing a little electricity tutorial or, basic walkthrough. And after many times of starting and never finishing, I think I'm going to try and get this thing done, at least part one. So, right off the bat, got Ohm's Law sitting here. Got a couple basic terms. We got AC, DC. AC would be like everything that you find in your house, which would be alternating current. And DC would be direct current, like you would find in your car with a battery and stuff like that. Like I said, got Ohm's Law over here. Got to have some math going on. But before we get into that, I figured I'd go into just some basic terminology and stuff like that, and how I actually, I didn't say it, but I've been working with electricity for 15 years now, working under electricians. I'm not an electrician, but I've been working for electricians, which means I go out and do all the work, and they look at it and go, oh, okay, yeah, it's cool. And then we get signed off on it. But, so pretty much I do all the work, so I know what I'm talking about. I just don't have the piece of paper that says that I know what I'm talking about. I just have work experience and stuff, which to me, that's more invaluable anyway. But, means nothing when you're going for a job, except for, yeah, I work with electricity. But anyway, we got the basic terms for volts, amps, and ohms. Like I said, we got Ohm's Law here. It's just a basic circle here. We got E, which is electromotive force here, which is your volts. You got your I, which is intensity, which is your amps. And you got R, which is your resistance, which is your ohms, which is represented by the omega symbol. Omega. But anyway, that meant nothing to me long ago when I first started. I had to have a friend actually come along and tell me, and he gave me the water analogy. I've heard the highway analogy. I've heard all these different analogies. The water one worked for me because I like to work with water. I mean, obviously, aquaponics and stuff like that. And how did I learn that? Okay, this is how I learned it, was with like a piece of pipe. So the way it was explained to me was electromotive force here, which is your volts. That would be like the size of your pipe. That would be like, this is a 3/4 inch pipe. That would be, let's just call this 110. So 3/4 inch pipe, let's just call a 1 1/4 inch pipe, you're, 240. That's still 110, or 120 volts. But anyways, so that would be like the size of your pipe. Okay, your intensity, which is your amps, that's like how much water you can flow through this pipe. And your resistance right here, that is pretty much like how much resistance inside the pipe that slows the water down. On a water analogy, kind of makes sense, but not exactly. But anyway, it didn't really click in that day. It took a few days, and once it clicked in, it actually really clicked in. But this is just Ohm's Law. You can go look it up yourself, and there are all these equations down here because they're all like right here. So electromotive force, which is volts, amps, resistance, ohms. So it'd be pretty much, you can work out any kind of math fraction that you need. E divided by I, E divided by R, I times R gives you E. Blah, 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 math problems. You can look that stuff up on your own. I decided to make a few circuits here. As you can see here, we've got a breaker coming right off the breaker and everything like that. This is normally the way everything is hooked up. Slight variations, depending on where you're from. I know, what is it, Europe? I think you guys are over there running 230, 240 instead of 110. Over here in the States, we've got 110, so I'm going to start with that. These are 110 breakers here. As you can see, I got two breakers stacked side by side. They're not really connected or anything like that, but they're just representing being in a panel box. And as you can see, I've got my black line, which is always your hot, and that's going to be your 120 volt coming right off of there. You got your white line here and your bare line. I've got them pretty much in the same bar because when I show you my panel box here in a second, that's the way my panel box is hooked up. The more modern way is your white and your ground. Your white is your common, which is kind of like your return line. If you want to think about it like water. Water comes in on the hot side, the black, goes all the way through, feeds this circuit, goes all the way through, feeds all these guys and everything, and then comes all the way back through on the white line and goes to there. It's kind of like your return type circuit. Kind of. Like I said, it's not exact, but it's the way I actually got into figuring out how this stuff actually works. But pretty much, you just have a wire, and again, you have to complete the circuit. That's why this all works. So you've got your hot line here, comes in, and it's going all the way in here, and it comes in on the backside here, which I have pushed in. As you can see here, they're just pushed in there. I do not recommend that. Please, if you ever have to work on electricity, use caution first, and use the screws on the side. I've been to so many calls, and trust me, it costs 95 bucks an hour, I think, here for an electrician to come out, plus the parts. This is a 59-cent outlet, and if that thing, we're going to replace that, by the way, if we come out, which is going to cost you like $3. You're looking at a $100 bill just for me to come out and replace this one outlet because someone pushed the connections in on the back. Quick troubleshooting tip, if you suspect that's one of the things, you can very, very gently kick, like just tap these outlets with your foot. Foot being, rubber sole, and nothing should, first off, you're not going to have anything on the outside anyway, but, all that stuff, rubber sole, be gentler impact and stuff like that. And if that is the problem, usually your electricity will come back on or off just because it's being jiggled. You usually know that it's pushed in on the back there instead of screwed in. And like I said, I recommend screwing it in. I've been to so many calls where I actually had to just pretty much, I could have used the same outlet, but our general rule was you give them a new outlet every time that happens, and you just use the screw down connections, which actually holds it down, which, if you don't know, electricity tends to vibrate, and it will want to go ahead and loosen itself right out of there. It'll want to loosen up that screw too, but if you screw it down real good, should be good. Anyway, this is taking a long time. Didn't even get to the breaker panel yet. But anyway, that's a general idea of how a circuit works. All the way out, all the way back. Well, let me come back to this. I'll show you the breaker panel, and then we'll come right back to this and get back into how a normal circuit will work. Alright, we're over here at my breaker panel. Yeah. May look like a jumble of wires and everything like that, but it's really easy when you actually start breaking it down. The very center here, these two lines of breakers right here all the way down, that's your hot side. And actually, I'll take you over here. I've got a spare panel box right over here, not hooked up or anything like that. As you can see, you've got your main power right here coming in, your main power right there coming in, and they come down on the side. One side comes over here, one side comes over here. So you'd have 120 volts coming in right there, 120 volts coming in right there. And that would supply this side right here with 120 and this side with 120. You take like a 220 amp breaker, like this guy right here. We'll see how it's crisscrossed here. Well, that's made so whenever you plug one of these breakers in, that it's getting, 120 from this leg and 120 from that leg. That way you get one from each, and you're not grabbing two from one. And the reason is that way you can keep everything even. And again, this is my secondary panel here, not hooked up or anything like that. And once I finally get into doing some solar and wind and stuff like that, I'm pretty much going to start using this as the breaker panel for that, for everything in the house, and then slowly just start switching it over. But obviously, high amperage stuff like the stove, water heater, and stuff like that, I'm not going to be able to do. But right over here, you can see we've got the two lines coming in. We've got one line going up over here, one line going up over there, the black lines. And then you got that bare, it's silver really, going all the way up. And it goes right up to here. And that, if you can see this bar right here on the outside wall, where Well, all the white lines, where all the white lines and the ground lines there are plugged into, they're pretty much like this right over here. It's just a bar. They're all connected, so they're all making connectivity. And let's see, get a little closer there. Yeah, and they're behind all these hot ones. Like I was saying about the offsetting of the breakers, that's where you get your hot lines right here. You get a 220 double pole, double throw breaker like right here. I believe this is 30 amp. I think that's like the stove or something like that. You got your red line and your black line. Hot and hot makes 220. 120, 120, 240. But that's pretty much as easy as it gets. Get your main lines coming in here. As you can see right there, other main line coming in right here, 120 on each line. And actually this is, I think, is a quadruple throw, quadruple pull breaker right here, which is my main 200 amp breaker. But yeah, so yeah, that's a typical breaker box here. I know it looks very complicated, but I mean, it's really not. I mean, it's really, if you have a hot line, it's plugged into this breaker line right here or this breaker line right here, and everything else, according to my house, is plugged into this line right over here, which if you go down here, you can see there's a bar that connects from over there on the left side right over here to the right side. And then it continues all the way up here where it's connected in with that silver line, and it goes back out to the main service. So that's pretty much it. I mean, 120 in, 120 in, and your common, or I guess in this sense, is really your ground. Newer applications will actually have this as well as a white line coming in from the street, and it will come in usually on the opposite side, and it'll have its own bar not connected to anything, and that will be, all of your neutrals will be plugged into there. But alright, well, let's go back to the makeshift circuits and talk about how a normal circuit is really run in the house. Alright, now we're back over here with my makeshift circuits, and as you can see, okay, we'll start with this one. So, like I was saying, the offset of the electrical, and this would be plugged into one leg. As you can see, like I said, you got your hot coming off, and it goes into the wire. You got your neutral, your ground, they're connected. So, normally the way it goes is that wire will come off, and it'll come off, and it'll be plugged into your, like a first outlet somewhere within. And this is a 110 normal, regular, everyday circuit that says bedroom, or living room, or dining room, or something like that. I'm not talking about like your stove connection or anything like that, but normally it comes in, you can see you got your white line coming in, your hot line coming in right over there, your ground normally is attached right here. I don't even have a screw, so I just kind of twisted it together. Sometimes it's done like that, but then it comes out. Exact same thing, white out of white, black out of black, and continues on. Here we meet up in a little junction, and pretty much all of the lines are tied together, as you can see. White is all tied to white, black is all tied to black, and ground is all tied to ground. And then it continues right on. We've got another outlet over here, and it just keeps on going like that. Every time you need a switch, you just kind of branch it off, and white goes to white, black goes to black, ground goes to ground, and you go off and do your switch so that you can have an outlet or a light switch up there, or a light up there, powered by a switch. Now with the switch, this is always very simple. As you can see, black is just hooked right to black, but black jumps off, and black goes right over here to the screw, and it comes in at the bottom, and that's where the power comes in. It's broken, and it comes back out at the top. And by broken, I mean literally it just breaks the line. Whenever you turn the switch on like that, that connects those two wires, and it, allows power to go through. If you were to suspect that this outlet was, or this switch was bad, and you were brave and disregard all the warnings that I'm going to say in here, don't try this at home and all that crap, if you were to disconnect this wire and just touch them together, that light should come on. because you're continuing the flow of electricity. Now, on the back side, yeah, it goes all the way up here, you got your light bulb, and then the white wire comes all the way back down, and it comes right back here, and it's connected with here. I would kind of look at that as kind of your drain line, if you were thinking plumbing. It's there, it's hooked up, it's ready to go. At a moment's notice, it's just waiting for, you know, the water to flow through. And the water would be electricity, which would be all the way up right here to this screw, waiting for the switch to turn on. And once it actually turns on, that would be like allowing the water to go through, and it's completing the circuit and everything. So on a little water basis, that would be how that would work. Another way, I did another 15 amp breaker over here. Another hot line coming off of there. Neutral and ground are hooked into well, I guess it would be the ground bar. But it goes off, and this would be like your typical water type situation, like your kitchen, your bathroom, stuff like that. They should all have a GFCI. Usually, if there's two bathrooms right on either side of them, they'll put one and one and then let it go at that. And the other side will have like a regular outlet like this, and there's no need for multiple GFCIs because then there's more chances of it to fail. But pretty much what it does is same thing. Comes in, hot side hot, neutral side neutral. And this one actually, if you look, you actually, if you can see that, you've got two different sides. Line right here where it's plugged in, and the other side is called load. Oh, it's hidden right behind there. Kind of can see it. But anyway, line would be your line coming in from the breaker. Your load would be your load going out to anything else beyond the GFCI that you want GFCI protected. So that took me a little while. Yeah, kind of slow. But that took me a little while to figure that stuff out. You hook them up backwards, and you put your line coming in, and you put it in on your load, and then you put your load on your line. It's not going to work. I mean, literally, it's not even going to work. It won't even reset. You won't get power to this outlet. It won't work at all, even though you got white into white, black into black. So, just a little advice on that. Oh, what else do we got here? So that's pretty much basic electricity there. At least 110. 220 pretty much is nothing more than you double up on your 110. The only thing is now you pretty much, unless you're talking about GFCI, you don't really have a common. So the way it was described to me, I'm not smart enough to figure this out, but apparently it comes out when you're talking about 210 here, or 210, 220, 230, 240, whatever you want to call it. You've got like 120 coming out on one and 120 coming out on the other. Now, instead of having a neutral, usually like this one will come out on this one and then come back in on that one. This one will come out on this one and come back in on this one. The best way it was told to me by an electrician was they're positive and negative electrons and they float in a wave kind of dealy, you know, like a typical wave. And apparently when it comes out, it's like up and then down and then up. Whereas when it comes back, it's down and then up and then down. But I don't know. It doesn't exactly make sense to me in my feeble little mind. But it kind of makes sense overall when you actually mess around with it. Now, the only other thing is whenever you're talking about a GFCI, here are two different GFCI breakers, a 220, 240 right here, and a 110. The only difference with these guys, as you can see right here, is you'll be running a common line as well as your ground and your two hots for a 220. So this little curly Q piggly tail right here would plug in right there on your common bar on the breaker panel, and your common from the wire would go, I believe it's this middle one right here. Yep. It would come right here on your middle one, and then it would be hot and hot right here. Your ground would just go to the ground bar. And same thing with your 120 volt you got your little curly Q here that would go to your neutral bar, which would be down here. And then you got your neutral that would be plugging in. Where the hell would that be? Yeah, that would be plugged in right here on, right? Hey, ¿dónde está? Yeah, I'm pretty sure it'd be plugged in right there, and then your hotline right above it, and pretty much goes right out. And then it would be GFCI protected. And GFCI is ground fault circuit interrupter. And if you don't know about them, they're awesome. They are so great. They've saved my life many, many times. They pretty much, the way it's been described to me anyway, they measure the amount of amperage, which again, you've got your voltage, size of the pipe, amperage, how much water is going through the pipe, and resistance would be the resistance within the pipe. But your amperage, it measures your amperage, and if it deviates, I forget what it is, 1/100th of an amp or something like that, it just trips itself. So pretty much it's detecting that there's going to be a short to, say, your hot tub where you're soaking in and you're going to get electrocuted. It just goes ahead and trips the breaker. Another thing, oh yeah, with the resistance, when we're talking about this, with the resistance in the pipe, another thing that's used in resistance here is a heating element. This is from a hot tub, but this is the same thing for, say, your water heater, your stove, your oven, all that different stuff if it's electric. Pretty much what it is you've got your two hots coming in. You got 110 or 120 coming in over here, 120 coming in over here. Yeah, all of those are the same. Stove, oven. Nah, I think some of the stoves are 120, but ovens are usually 240. The water heaters usually 240. Hot tubs are usually 240. You got 120 coming in, 120 coming in. And inside here is pretty much the same thing as like the filament in a light bulb. And it heats up. The byproduct of resistance with electricity is heat. And so it heats up. And just like those old school 60 watt, 100 watt, 75 watt light bulbs that you would use, you turn them off and you got to like wait a few minutes before you can unscrew them or use a rag or something like that because they're so hot. Same thing. That kind of filament type dealie is inside here, and water's flowing through here, and pretty much it's heating up the water. Let's see, what else do I have here? Meters. I've got a couple of different meters here. You got your regular old digital type meter here with your standard probes. I can't figure these things out, man. Be perfectly honest, my favorite is right here. It's a Fluke T5 600. My baby right here. It's a Fluke T5 1000, and the only difference between 1000 and 600, that can handle 600 volts. This can handle 1000 volts. I like to call this the stupid person meter. It's very it's very easy to use. As you can see right there, the first click is volt, defaults to AC. You connect it to DC, it's gonna measure it. And you use your probes right here on the back, and bam. Amperage, it automatically defaults. You use your little dealie right here. This you cannot just put around a wire and measure it. Why? Because you got your hot and your neutral going through there. They neutral each other out, and you'll get a 0 rating. So what you've got to do is come down here and actually go around one of the wires. Right here, I'm going around the hot wire. But it doesn't matter. Just go around one of the wires. You can actually measure it in amps and ohms. You always, to my knowledge, I haven't run across an application yet where you run a test with ohms with the power on. You always turn the power off. Use your probes on the back. And that would be something you would do to, say, this heating element and check and make sure that it's got 12.5, 13 ohms, which is what it should have. I tested it right before, it's got 30. So it's definitely bad. But, and usually with a heating element, they're pretty specific. They're like dead on at 13, and if you're 14 or 12, it's dead. But, yeah. What else do we got here? my little light switch circuit there. Oh, my transformers. One other thing I would just gonna go ahead and talk about. There's a bunch of different things with electronics, and electronics is nothing but electricity broken down with a bunch of switches. That's why I love messing around with hot tubs and stuff like that. For this heating element right here to actually work, first off, you have to have a temperature sensor that senses, hey, we don't have enough temperature, and a temperature sensor kicks on and kicks it in motion. That turns the pump on, which pushes water across this heating element here. That tells the flow sensor or the the flow sensor or the flow switch. It tells it that it's actually getting water going across there, and it can actually apply power to this without having it burn right up. Then you have to have your overheat sensor, which would be after, which when the water is running across there, if it's getting too hot, the overheat sensor, it's yet another switch. They're all just a bunch of switches, and that would tell this whether to turn on or off. But that's pretty much what most of electronics are. One other thing that I wanted to jump into real quick is transformers, and I always thought these were magical devices. I had no clue they were this dumb. But transformer, everything's got a transformer. Your phone, everything. This is a transformer right here. It comes in at 120 volt and goes out at 12. It was for my tablet. So right here you get 120 volts coming in, and I believe it's just the hot side, not the neutral. I believe the neutral actually just goes right down to the wire here. But the hot side, how does it magically go from 120 to 12? The dumbest way ever. I always thought it was just, no, you take a big wire and you make it neck down to a small wire. Well, that'll just burn up the wire. So the way you do it is you actually just keep doing circles and circles and circles until the friction of that line breaks down 120 volts all the way down to 12 volts. And then it comes back out this line and goes to the end of the cord and charges your device. Another example right here is a volume control for music and stuff like that. This is for like in the wall type control, where you put it in one of these goofy little boxes and put a cover plate on there, and it looks pretty in the wall. But as you can see right here, these are two transformers right here on the end here, and that is exactly what I'm talking about. It's nothing but wire right there running around this thing and around and around and around and around. But it's got multiple settings on the side here, again in the middle, again there on that one and that one. So you actually get multiple different, it's a little bit harder than that. This right here where my thumb is, that actually controls different settings to go to these different contacts right here, which is different lengths of pipe, or different lengths of wire, which breaks down the electricity. Alright, well, yeah, so that's the end of that. The only other thing that I was going to bring up were relays, contactors. And contactors are pretty much just another switch that are usually electronically controlled. Usually you'll have 220 volt type deal, except it'll be controlled by like 24 volts or 12 or something like that. Get into that next time. Have to recollect my thoughts. I had 1,000 things that I was trying to go over with this video. Probably went over 4. But, yeah. But I made cool little circuits, man. But, yeah, anyway, I just wanted to throw this out there. This was the main thing I wanted to get at, was the circuitry right here, like how a circuit really is actually put together. This isn't every circuit, of course. This is just one that I threw together. But that's how easy these circuits really are. And it's pretty much like power coming from your breaker. Everything else comes back to your respective neutral or ground bar or the same bar. And you just have wire going out. And these are all in series, and pretty much, which means one can fail and the rest will keep on working, because they're all interconnected. Whereas DC, like your car, usually those are if one fails, the rest fail kind of thing. And again, it's completely conjecture. You could go ladder design and stuff like that, and it still can work. But for the most part, that's what's going on. So anyway, thanks for putting up with this crap. It was a lot of talking, not a lot of knowledge. But if anybody learned anything about that, that would be awesome. Like I said, it was just something as dumb as somebody explaining electricity as water. And you could do the same with like a highway or something like that. 2-lane highway, 1-lane highway, coming, going, you know, stuff like that. And that actually makes a little more sense, but to be perfectly honest, I learned because of the water pipe, because I love working with water. So that actually helped me. I figured I'd throw that out there, and if anybody else can learn just the smallest amount of electricity knowledge and actually go to the Google machine and start looking things up, figure things out on their own, then I feel like I actually made a difference in the world. Look at me go! But, yeah. Oh, I'm so proud. But, yeah, it was just a little walk around. I figure I'm going to try to do a little electrical tutorial, some troubleshooting and stuff like that in the future. So I'll be trying that in the future. Hopefully it won't take me like a month or 2 months to actually get the next one out like it did for this one. I've been thinking about this for quite a long time. But hey, I finally got it out. But anyway, till then, don't forget to like, favorite, subscribe, all that fun, happy media stuff down below. Leave a comment. Let me know if any of this was relevant, if it actually made sense. Maybe my next video will be because you don't understand what the heck I'm talking about because I'm rambling like an idiot. Let's go for it. I got a lot of knowledge and, well, I say knowledge, but it's basically I can get stuff done. I don't know if I can actually express it and show how I can actually get it done. So if I'm actually helping anybody, please leave a comment down below. Let me know that you actually learned anything, because that would be amazing to me. But until then, I'll try to figure out how I'm going to do the next video. Make up a couple more mock circuits. Maybe I'll even apply some electricity and do some troubleshooting type things. How to figure out if your outlet is bad or not. So until then, I'll catch you later. Don't forget to do all that fun, happy media stuff down below, because that's fun. Otherwise, I wouldn't say it was fun. Anyway, thanks for putting up with me. Later. Alright, since you made it this far, if you made it this far, I figure you need a little comic relief. This is a hot tub pack. As you can see, main hot tub voltage coming in right here, heating tube right here. The heating element goes in like this and attaches to these copper wires right here. Blah, 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 blah. Anyway, little funny story. I was called out to a hot tub that was acting erratic, and it was not really, I don't know, it was off the map. It really wasn't following any kind of guideline. Long story short, I ended up finding, I don't remember where it was. It wasn't exactly this pack. It was a different kind. But we'll just say right here on these high voltage lines right here, these are 120 volts each right here. Both of them go into the heating element. And we had a whole army of ants that were walking across. And as they were walking, they would hit the electrical contact. And like, it was pretty much one after another. You just see them like, poof, and it would just be a little puff of smoke and they would evaporate. And it would just be like every other ant or something like that. I guess that's why they kept going, because some of them made it. And they would just keep on going across and poof, poof, poof. It was pretty crazy. But anyway, that was some funny story. That way you can at least have a little bit of, well, you can pretend like you laughed at that. That way you can pretend it was comical. Later.